Hi everybody and welcome back to the channel. Today we are going to explore the concept of a proper bundle of lines, a set of lines that all pass through the same point. We will see how to determine their equations both when the center is at the origin and when it's at any other point. Let's get started. In elementary geometry, a proper bundle of lines refers to the set of all lines in a plane that pass through a common point called the center of the bundle. Now, let's determine the equation for an infinite set of lines passing through a given point. Since each line in the bundle has a different slope, the equation must include a variable angular coefficient. We already know that a line passing through the origin, except for the y-axis, is represented by the equation y equals mx, where m is the slope of the line. Please refer to this video if you want to know more about lines through the origin. I will leave the link in the description. Therefore, the equation y equals mx, where m is a variable in R, represents the proper bundle of lines passing through the origin, excluding the y-axis. To obtain the equation for all lines passing through the origin, including the y-axis, we can set m equals minus a over b, which gives y equals minus a over b x, or equivalently ax plus by equals 0. Since a and b are variables in R, this equation represents the entire bundle of lines passing through the origin. When b equals 0, the equation reduces to x equals 0, which represents the y-axis. Now, let's determine the equation of a bundle of lines centered at point C x0, y0, different from the origin. We can derive this equation using two methods. The first is the translation of the coordinate system, and the second is the translation of the bundle. We will use the first method. So consider a bundle of lines centered at C x0, y0. We apply a translation tau that shifts the origin to C. This is capital X and this is capital Y. In the translated system, capital X, C, capital Y, the bundle of lines is represented by capital Y equals m capital X, because all lines are passing through the origin. Applying the inverse translation tau to the minus 1, which restores the original coordinate system, we will obtain the equation of the bundle in XOY. Now the translation that shifts the origin to C, we have that X will be capital X plus X0 and Y capital Y plus Y0, and its inverse will be capital X equals X minus X0 and capital Y equals Y minus Y0. So we now substitute these into the equation capital Y equals M capital X. So we have that this is the equation of the bundle in capital X, C, capital Y. We apply the transformation tau to the minus 1, and we get y minus y0 equals m x minus x0, and this is the equation of the bundle in x, o, y coordinate system, where m is a variable in R. Now, this equation here represents the bundle of lines centered at C, x0, y0, excluding the vertical line x equals x0, since vertical lines have an undefined slope. Now, we want to generalize this equation by including all the lines passing through C, x0, y0. So to do so, we set m equals minus a over b, which gives y minus y0 equals minus a over b x minus x0, or equivalently a x minus x0 plus b y minus y0 equals 0, where a and b belong to R. Since a and b are variables in R, this equation represents the entire bundle of lines passing through C, x0, y0. You can also observe that for b equals 0, we obtain x minus x0 equals 0, which is the equation of the vertical line passing through C parallel to the y-axis. Thank you for watching this video. I hope it was helpful. If you'd like to learn more about this topic, please let me know in the comments. Keep practicing, and see you next time.